All right, how about one last video for the entire, not just section, but the chapter, huh? All right, two more examples to get through. These are going to be fairly quick, at least I hope so. So back to our blood drive question, okay? 7% of people have O negative blood. We need to get 20 units of O negative. 400 people show up. Find the mean and standard deviation and interpret the mean, okay? So our mean, remember, is n times p, or in this case, 400 people times those 7% that are going to be O negative for a total of 28. And the standard deviation is the square root of n times p times q. So 400 times those 7% of people who are O negative times the 93% of people who are not, and we get 5.1, okay? And interpret the mean, we're not going to forget to do that. So if 400 people give blood, we expect about 28 of them to be O negative. Okay, simple enough. If you don't want to say the word about, that's okay too. You can say 28. That was a right on number, no rounding that needed to be done. All right. How many O negative donors would be considered to be an unusual number of O negative donors? And we're going to talk about boundaries. Okay, so again, when we talk about unusual, we've got that less than 5% number. Well, I don't know how to figure out where the less than 5% probability falls. Well, I do. You don't. We'll talk about that in an upcoming chapter. So we can't do that. We don't have anything about percentiles. And so we're back to our two standard deviation method here. So we can look at the mean plus and minus 2 standard deviations because, well, we just figured those out. So if we do 28 plus and minus 2 times 5.1, that is going to give us a lower boundary and an upper boundary. If you do the negative first, the subtraction first, that'll give you the lower boundary. So 28 minus 2 times 5.1 gives us 17.8. And then if you change that to a plus, that gives you an upper boundary of 38.2. Okay, so this range in here, what we're seeing in between, this is what's typical. Okay, we would expect to see somewhere between 17.8 and 38.2, or let's say, 18 and 38 O negative donors. But we're asked to explain what would be an unusual number of O negative donors. Okay, so based on the mean and the standard deviation, so I'm going to use some abbreviations there, the symbols for mean, and then you can use SD or you can use the sigma, I don't care. And 400 people attending the blood drive. Because these numbers don't apply if we've got, only 200 people that show up, or if 1,000 people show up. All right, so based on the mean and standard deviation and 400 people attending the blood drive, it would be unusual to have, okay, now let's talk about whole numbers of people, okay? Would it be unusual to have, you can say less than 17.8, I'm okay with that, okay? It would be unusual to have less than 18. You can say it would be unusual to have 17 or fewer, because 17 is included outside of that boundary. Okay, so however you want to phrase it, I'm going to say it would be unusual to have less than 18 or more than, now again, I'm not, you can say more than 38.2, that's fine. I'm going to say more than 38 O negative donors. right. Moving on to this next one. So back to Zyrtec, we're going to do pretty much the same thing that we just did up above. Okay, very similar in terms of what we're being asked. So we're asked to find the mean and the standard deviation. So the mean is n times p, or 30 times 0.14, giving us 4.2. The standard deviation is the square root of npq. So the square root of 30 times 0.14 times the other 86% of people who don't experience drowsiness, 1.9. And here it says interpret the mean and the standard deviation. So we can do that in one fell swoop here. So let's say on average, about 4 of every 30 Zyrtec users will experience drowsiness with that number differing by 2 people on average. Okay, so about 4 of every people will experience, Zyrtec users will experience drowsiness. That number will differ by about 2 people on average. And so that number referring to the average of 4. If you want to do a new sentence, you can do that as well. Okay, but I kind of threw those into one. Give the boundaries for an unusual number of patients out of 30 experiencing drowsiness. So again, that whole 2 standard deviation thing. So mean plus or minus 2 standard deviations. 4.2 plus or minus 2 times 1.9. On the low end, that gives you a 0.4. On the high end, that gives you an 8. Okay, so the boundaries, it's unusual for, you can say less than 4.4. You can say it'd be unusual for nobody to experience drowsiness if you want. That would probably be the more common sense way to say it, but unusual for less than 0.4 or more than 8 of 30 Zyrtec users to be drowsy. Okay. All right. That wraps up not only sections 5.2 and 5.3, but chapter 5 as well. So go back through, now that we've done everything, go back through and make sure you've kind of picked up on all those fine details, all those fine points. Go back and review what a probability distribution is, what a probability distribution with the histogram looks like, the shapes, when to use that 2 standard deviation for unusual, when you can say 5%. Go back and look through CDF, PDF, what's the difference? There's a lot of stuff in a very short amount of sections there, and all of it is going to be important, not only in this chapter, but for the rest of the course.